Welcome to the Math 8 Unit 3 CSA study guide. This is the end of Unit 3 test study guide. And let's get started. Using the scatter plot, answer parts A through C. Part A, interpret the graph and describe whether there is a correlation or not. Justify your answer. Okay, well, as we look and we go as the hours playing sports, your input or x-axis goes positive towards the right. We have a trend of increasing numbers going positive up. So we have positive correlation. And then we need to justify your answer completely. As inputs or x values increase, y values or outputs also increase. Using the scatter plot, draw a line of best fit. Okay, well, as I look to draw a line, I'm going to try to target a y-intercept that's very easy to write an equation for. So I'm going to put a dot at 5 here and draw my line of best fit. Looks about like that. And I like this point here, so I'm going to label this point as 0, 5. I'm going to label this point as 3 and 9.5. Okay, using the scatter plot, draw a line of best fit. So done with A and B, write the equation of the line of best fit. Let's put down what we know. We know that equation of a line is y equals mx plus b. So I need to find the slope, also known as m, as the change in y over the change in x. And so I'm going to label this x1, y1, x2, y2. To find the slope, I'm going to subtract those. y2 minus y1, x2 minus x1. So I just plug them in. 9.5 minus 5 over 3 minus 0. Feel free to pause the video at any time if you need extra time. So this is 4.5 over 3, and that reduces to a very nice number. They both share 1.5. This is 3 over 2. 1.5 goes into 4.5 3 times. It goes into 1.5 goes into 3 twice. So there's my slope m. The other is very easy. The y-intercept, b, is equal to 5. And that's this part of the equation. So just like we did with marble slides, you're only looking for the slope m and the y-intercept b. So now we can write the equation y equals mx plus b, and we're going to put in for m and put in for b. Y equals 3 over 2x plus 5. I'd like to put a rectangle around my answer. Construct problem 2. Construct a data set that has no correlation. Okay, well let's put some dots in here randomly. So let's put one more. Maybe one more right about here. So as you can see that I have randomly placed lots of data points in here. There's no trend. As I travel positive, there's no trend of correlating positive up. So describe how you know your data set has no correlation. A sample solution could be as x increases, there is no correlating trend of y values increasing or decreasing. Something to that effect. Okay, problem 2. Problem 1 is 4-point. These are scored on 4-point rubrics, so 4 points for number 1. I believe 4 points for number 2. I'll recheck that. It could be 2 points on the rubric, but I believe it's 4. Number 3, Megan is opening a gym. She is offering 4 payment options. Use the options on the left to answer the questions on the right. Okay, so we have all these questions here, and if I scan the problem, I have option A. She's not going to charge a sign-up fee. She's going to charge $3.50 a month. So we have proportional linear relationship. And I know that in that situation, the line passes through 0, 0. And so B equals 0. So we're just dealing with y equals mx. And we have the rate, because we know when it says per, that's our rate. Y equals 3.50x. So thinking ahead to the essential question, this problem will answer essential question 2. How are the different ways you can view a linear relationship? We can have words, we can have a table, we can have an equation, and we can have a graph. Let's look at this, how much they're charging in the table. The change in y is here. We're looking for the change in y over the change in x. So as this table changes, it goes up 5.50. And this changes by +1. And this is going up. Here the change is +2. And we see that the change here is $11. So that's a good thing. This one changes by +3. And then the change here is plus $16.50, and then we have a final change of +6, and the change here is plus 33. So that's a really good thing, because we know that our rate of change and our equation for this y equals, it changes by 550 for every one. 5.50x plus, it starts at $10. So we can compare those rates right there. Here, this goes up by quite a bit, $7.50 for every month, plus 5. Remember, X is for months. Let's go back up to the, she's offering 4 payment options per month. Okay. Here, it starts at 0, it looks like 25. And we're going to be looking for 24 months. So real quick, easy way to do it is just to go to 24 and take it straight up to right here. 24, comma 90. So that Y, the output, is money. So that's $90 after 24 months. Let's complete the statement below. After 2 years, 24 months, she will spend blank. So we're going to put in here y equals 3.50 times 24. $3.5 times 24 is going to equal 84. And again, our output's in dollars. So I'm going to put the answer over here. And I'm going to do 5.5 times 24 equals 132. plus 10. And I get y equals 132 plus 10. Y equals $142. I'm going to put that there. Option C, this looks very expensive, 7.50 times 24 plus 5. That's going to be $180 plus 5, and I get $185. And finally, option D, we know after 24 months she's going to spend $90. So that's part A. Part B, which option is going to cost the least amount of money after 2 years, which is 24 months, and justify your answer. So we would go with option A will cost the least. And to justify your answer, we solved all of them, and we noticed that option A and D are the best options. But option A is better by $6, because $90, 84, 90 minus 84 is $6. Again, 4-point rubric is the scoring. Problem number 4. There are 2 companies that offer different wage options. Company A gives its wage information in the graph. Company B gives their wage information as a table. Use this information to complete the sections below. For part A, write the equation and complete the function table. For company B, complete the graph and write the function. Write the equation. Okay, again, the equation we know is y equals mx plus b. So I'm going to need to find the slope of this problem. Let's look at 0, 10. And I know that that's 0, 10. And then I see, this is very nice, 20, 15. So the slope is m, and it's equal to the change in y over the change in x. The change in y, this is a comma, it changes by plus 5 for every change in x, 20. Or I could write as m equals 1 over 4. And I know b equals 10. I need to write that equation. Y equals mx plus b. We're looking for slope and y-intercept. 1 over 4x plus 10. Okay, so I know 20 here is 15. And look, I even know that this is 40 is 20. So I'm going to put that here, 40, 20. So these are changing by, that's a change of 20. So this would be 10, 30, and 50. And if I think about it, for every other one, it changed by 5. So everyone has to change by $2.50 to keep it. $12.50, $17.50, $22.50. Now I just need to see my change in y here, because these are changing by plus 10, plus 10. These are changing by plus 2. That's my change in y, delta y, plus 10, plus 10 plus 10. So my change in x is over here is 10. So my slope m is going to equal change in y over change in x. So it changes for every 2. It changes 10, which equals 1 over 5. So I have my slope. I also know what b is. B is $12 to start with. So my equation is going to be y equals mx plus b. I'm going to put in for m, 1 over 5. Then x plus my starting point is 12. So I have my two equations, check. I've got my function table. Now I need to graph this here at 0, 12. These are going by ones. These are going by, looks like twos. 2, 4, 6, 8, 10. So I have to be really careful here. I'm going to 10, 14, 20, 16, 30, 18. You'll know you messed up because if you messed up, the dots won't line up. 40, 20, and 50, 22. And the dots appear to be in a straight line. Which company's wages have a higher rate of change? That's rate of change is your slope. So which slope is larger, 1/5 or 1/4? Well, 1/4 is a larger number than 1/5. If I think I have a 1/4 of a dollar would be 25 cents. And 1/5 of a dollar is only 20 cents. So let me say that it's this. That's company A. And you can make a simple statement like the rate of change or the slope. Company A, rate of change for company A is 1/4, and that is greater than company B, rate of 1 over 5. Oh, pardon me. There we go. So the explanation would be that you can compare them with a greater than symbol. And we did that also in Marble Slides when we limited the domain so that you had great practice in that. Which company has a higher initial hourly rate? That's pretty easy. You go to 0 months and you can clearly see that company B initially was paying $12 an hour. So company B initial wage was $12, and that is $2 more than company A initial wage, which was $10. And that's the end of part B. We're almost done. We have some essential questions to finish up. Essential question 1, why is it important to understand the different representations of a linear function? 2, using multiple representations, how can I recognize a linear function? 3, how can I represent real-world situations using bivariate data? And 4, how do you demonstrate the difference between a proportional and a non-proportional relationship? They're big words. Again, let's focus on the sheet that I already had provided for you. This is also will be available on the Google Classroom. Let's look at 2 because it's the easiest one. The answer for 2. You can recognize a linear function, and we've practiced 4 ways. 1, you can make a table of values. You can put it in a graph, and if it makes us a line, except for the vertical line. So you're looking at a table, you're looking for a constant rate of change, graphs. You're looking for a straight line, or all the data points line up. You can look in the form of an equation. Y equals mx plus b is the slope-intercept equation. There's also we've looked at another form. We looked at standard form, or in a verbal description. One input has exactly one output. Okay, let's go back up to 1. Why is it important to understand the difference between the different representations of a linear function? Okay, so the key to this one is to think that if you can use multiple representations, then depending on the problem type, it may lend itself to a better representation. We're talking about when you have some data, maybe it's easiest to understand it as a verbal description. It might be better to write it as an equation, or it might be better to show it as a graph. Okay. 3, how do you demonstrate the difference between a proportional and a non-proportional linear relationship? This one we talked about a lot. We know that it's proportional when it goes, the line passes through the origin. 0, 0. And that's part of this answer here is 3. It will include the origin. An ordered pair 0, 0, or B will equal 0. And they talk here in quite a bit of words, so don't get too bogged down. We know that B equals 0 is another thing when we're talking about Y equals mx plus B. B equals 0, so B just drops out, and we just have this Y equals mx. Finally, the last one, how do I represent real-world situations using bivariate data? Okay, well, representations that are algebraic, the functions, numerical in tables, graphs, and verbal descriptions can help model real-world situations using bivariate data. You can also add to this answer that you can look for correlation, positive and negative correlation. You can build a line of best fit to to model real world situations. Please study hard. The test begins on Wednesday. We're going to be breaking it up into 2 days, Wednesday and Thursday, and then retakes for people that were absent will be on Friday. Good luck.